Hello, I'm Dr. David Gibby. I'm the father of the International Master Gardener Program. Today we're going to talk a little bit about houseplants and how the care and how to make your brown thumb turn green. I think possibly we might start with some questions. How often should I water? How much should I water? What is the best soil mix for my indoor plants? How much gravel and activated charcoal should I use in the bottom of my pot to provide drainage? Why do my leaves yellow, sometimes all at once, a bunch of them? And how much and how often should I fertilize? When we talk about plants, there's a few things that are probably a good idea to keep in mind. Let's just take our typical plant here. That may not look very typical, but we're going to call that a typical plant. We basically have two parts, two main parts, the root zone area of the plant and the upper area of the plant. Now, the root zone is, the environment of the root zone is obviously very different from the top. And one time I actually planted some plants upside down, some tomatoes, to see how they would do. I found out three things. Number one, they didn't bear much fruit. Number two, they were very hard to pick, and finally the getting at them to pick was really difficult. Obviously, that's not true. None of them survived, and the reason is the environment of the top of the plant is vastly different from the environment of the bottom of the plant. Let's look at the top of the plant first, because that's an area we can discuss with a little more freedom. There's not a lot of things we can do to the top of the plant to control its environment. There's only a couple. One is the amount of light that we give the plant. Now we control that with an indoor plant simply by moving the pot around in the home. Is it in an area of the home that has bright light, has good windows, you keep the drapes drawn somewhat, or is it in a darkened corner of the room that doesn't get very much light? And if it's the former, you're going to find that plants will do much better than the latter. In fact, if you got an area that's quite dark in the home, you're very limited as the kind of plants that you can grow in the home. That might be restricted to things like philodendrons or pothos. Upright plants, maybe dracaenas and perhaps spathiphyllum or something along those lines, because they'll tolerate lower lights than will a lot of the other indoor plants. The other area that we talk about in terms of plant care is in the upper part of the plant is relative humidity. And we can't control that nearly as well as we can controlling the light, simply by the amount you let in through your windows or where you orient the plants. However, there's a few things we can do to enrich the relative humidity of the plant. Some plants have a real critical need for extra humidity, such as, for example, if you're going to grow camellias or gardenias indoors, you'd find that in a dry environment, such as, say, Arizona, Utah, California, you're going to find certain areas of California that are very dry, you're going to find they'll grow fine. But indoors, they're going to abort their blossoms because the relative humidity is just too low. So if you want to grow those in an area that has a dry environment, there's a couple things you can do to increase the possibility of getting the plants to actually bloom and produce flowers. One, and the easiest one, is to just get a tray and you fill that full of water and you put a brick or something like that in there. Your pot sits up on that brick so that the plant will get the humidity that's evaporating from the water in the pebble tray, but it's not sitting down in the water. The other method is to simply get a mist bottle, like a starch bottle, something like that, and fill it full of water and put it behind the plant. I have friends that do that, and every time they walk by the plant, they've trained themselves to pull that bottle out and mist the area around the plant. If it's a large plant, that's all you can do. But it works. It's just a lot more work than I care to do. Those are the main factors in the top of the plant. let's talk about the root. Okay, the root of the plant. You're going to find, if we enlarge the root, that there's some very, very tough, highly fiberized cells at the bottom of the root that allow the root to punch through the soil. And if you get back, and you have an area in here where you have a lot of cell division taking place, and then up a ways, the cell walls elongate and form some very fine roots that are single-celled that we call root hairs. And if you look at a typical root, if you even take a plant out of a pot and look at it, if the roots are healthy, you look just behind the root tip, you're very likely to see these fine root hairs that we talk about. This is where the bulk of the absorption takes place. It's not back up after the root gets woody, nor is it down here on the tip where it's where you're basically filled with stone cells or whatever to allow the root to grow through the soil. It's back up just a little ways. We call this the meristematic or growth zone. Back up when your cells are elongating, they form these wonderful root hairs. And so the root there at that point is getting us, that's where the absorption of water and dissolved minerals takes place within the plant. And it's very important that we keep these root hairs healthy. Now let's talk about a few other things. Relating to the root and relating to the soil environment of the root. Now, if we take we're going to draw something like this. We're going to call that soil pores, like starting from very large pores and working way down to very small pores. And the larger pores will fill full of water to allow the water to run down through the soil. But the smaller pores, as the pores get smaller, of course this has been magnified many times, eventually you get to a point where small pores in the soil will hold water against gravity. And we call those capillary pores. And the definition of a capillary pore is those pores that will hold water against gravity. Now that on the heels of that follows another definition, that is, saturated soil is soil in which all of the capillary pores are filled with water, and the larger non-capillary pores are filled back with air. If these are full of water too, then we say the soil is above saturation. But if these are filled back up full of air and these are full of water, that soil is at saturation. That's the first thing that comes from that. The second is that water only moves through the soil as far as it saturates. So if I've got a lot of pores down here, and the pores just stay this point in the soil up to this position have been saturated, the pores, and these have drained free, the water will not move from these upper capillary pores to lower capillary pores unless there's a little bit more flowing into there in these non-capillary pores to allow the water to move down. And you can see that in a garden. If you're irrigating a garden and you have a furrow of water that's going through the garden, then that furrow of water will be a large back a ways from where the water is trickling along. You'll see a nice large furrow of water. But as you get close to where the stream is beginning, you'll notice that the water is just down to a little trickle. And what's happening is that the capillary pores are drawing those waters, the water from that volume, that furrow of water, into the capillary pores, and until they're somewhat satisfied, you don't get much of a stream flowing over top. So capillary pores are really important. It's an important concept. But so are these, because the non-capillary pores supply the air that keep the roots healthy. Now let's talk about that just for a minute. Okay, a lot of us have seen the formula for photosynthesis. It's water plus carbon dioxide goes to form sugar, which is C6H12O6. 6 should be down here. That's basically the basic form of sugar. This happens, of course, in the presence of light. So in the presence of light, carbon and the chlorophyll molecule of the plant, the green portion of the plant, water and carbon dioxide will bond together to form sugar, and it also releases oxygen. Okay? Well, that's what happens in the light. But plants in the dark, like say at nighttime, the process reverses, and sugar and oxygen will form carbon dioxide and water in the plant. Even in your big leaves and up at the upper part of a big tree, this will be taking place. But there's one part of the plant, obviously, where they're never in the light. And of course, that's our friendly root zone. These plant parts are always in the dark, and so they're always dependent upon the upper part of the plant to supply sugars and other metabolites to allow the roots to stay healthy. They need energy to grow just like the top of the plant. And so they burn sugars and they absorb oxygen and release water and carbon dioxide back into the soil environment. Now, if I then take a plant and I water it and I deprive that root from oxygen for a prolonged period of time, the root will die. It has no other options. It can't die. Now, for a short period of time, the plant has two metabolic pathways. It has the aerobic pathway, in which this is basically an aerobic pathway, or this way actually is the aerobic pathway if you're having metabolism of sugars. But the plant has a very interesting other pathway, which is anaerobic. The only problem with the anaerobic pathway, it's like storing your clothes in a closet. Eventually the closet gets full of clothes, you can't get any more in there. And that's what happens with the plant and in the roots. If you keep the plant from getting oxygen back in, which allows you to clean the closet out by reverting to the aerobic pathway, and the plant will simply shut the process down because it can't get any more clothes in the closet or any more of these products of the anaerobic pathway to be metabolized. So as a result, that shuts it down and the root dies. Now, the key then to having healthy roots is simply this. You got to supply it with water, you got to supply it with dissolved minerals, and you have to supply it with air and air exchange. In other words, the soil, the area above the pot up here, has to supply air down to the roots. And those roots have to be able to release carbon dioxide, and of course the water can go into the soil no problem, but it has to be able to release carbon dioxide and absorb oxygen on a continuing basis for the roots to remain healthy. So people say, well, how do I know how much water to give it or how often to give it? Well, that brings us to another interesting little phenomenon. And we've kind of hinted at that already, but if I take a root ball, let's just say I got a nice big one like this. And the reason I use this is because some time ago I had a fellow call me, and he asked me if I'd come out and tell him why his large ficus tree was dying. And I said, well, I'm really busy. I said, can I come out in a week or so? And he said, no, got to have you today. And I said, well, I can't come today. I'm really busy. And I said, but if you can cut me some slack, I'll come out in a few days. And I noticed about half hour later, this van pulled up in front of the shop, and this big old ficus was hanging out of the back of the van. He had borrowed someone's truck and rushed over. And prior to his leaving, I asked him how he was caring for the plant. Oh, he says, oh, I'm watering it every day. I said, well, you're probably rotting off your roots. And he says, no, I don't think that's true. And so anyway, when he pulled in, I was going to go out there and show him how he was really, truly rotting his roots away with overwatering. So I went out there, and it took two of us because the pot was 20 inches across. And between the two of us, we lifted the back of the plant up, we popped the pot off, and I was rather surprised at what I saw. Here's the big stem coming up here, and all the smaller roots in this whole zone on the top of the pot were rotted off. You had the big roots that were going down to the bottom, but this upper area of soil, these roots were all rotten. This was just like a swamp. You get down to this area, down in here, the roots were in an area where the larger pores were not filled with water, they were filled with air. And so this here, I call this JR, just right. And all this was right full of nice roots. And down here, I call this the Sahara Desert. You could see a few roots, but they hadn't received water other than what was supplied from the upper part of the plant for a long, long time. So these roots were poorly developed and looking pretty sad because they were so dry. So what he was doing is he was adding a little bit of water. He was keeping this oversaturated. We'll abbreviate saturation. This one here was saturated, but the larger pores had been allowed to fill back full of air. And down here, these were getting nothing. So what's the answer? Simply, give it enough water to allow it to saturate all the way down. And then allow it to dry back out. It's nice if you've got drainage, so the extra water can flow out. But for a few, you can't just immediately give it water again, because then you're keeping all those non-capillary pores filled with water and not air, and the air is just as important to the water. And so that's kind of the key to watering then, is to water enough to move the water through the soil, but not so frequently or so much that you keep the plant above, the soil around the plant above saturation. Now the question is, how do I know when to water? And the answer is, you feel the soil. If it's a great big pot like this, I stick my finger way down in there to see if it's dry. If it's a small pot, like a 6-inch pot or a 4-inch pot, I scratch the surface of the soil to see if it's dry. But I'm telling you, the secret to a green thumb is a dirty fingertip. If you get that finger dirty and feel in the soil, and if it's moist, you don't water it, because there's enough in the capillary pores to keep it alive. But if you feel it and it feels really dry, and you think, oh, this plant's probably dry quite a ways down, then it's time to give it a good drink. And you have to kind of learn how much water it takes to move the water all the way down there. It's easy if you got a plant that has drainage, because you can water it. In a big pot like this, you give it a couple quarts of water, come back an hour later, how much flowed out the bottom? How much is in the saucer? Well, if there's a cup in the saucer, give it a cup less next time. On the other hand, if you got plants without drainage, that introduces another interesting question. So if I've got 2 pots now, neither one of them have drainage. Okay, here's the question. What should we do to provide drainage? A lot of people say, in fact, if you look in a lot of textbooks, they'll say, put rocks in the bottom. And the rocks can absorb the extra water that you might give it. So let's look at that possibility. We're going to put some rocks in the bottom of this. Just one of them. The other one we're going to leave it completely filled just with regular soil. Now, in both cases, let's say we overwater it a little bit. So I've got freestanding water about here in that plant and about here in this one. Now this plant, I've got regular good soil that goes all the way to the bottom. This plant, I've got soil down to here. This one has capillary pores all the way up and down. So what will happen with this plant, if I overwater it, this water will be drawn back up by the capillary pores. And so if I'm smart, I'll say to myself, self, that plant took a long time to dry out. Perhaps I gave it too much water. So I would adjust my watering back maybe half a cup or a cup of water, not give this quite so much. In this case, I don't get a signal because my capillary pores end right here, right there. Where that coarse stuff is, there's no more capillary pores. So this will not allow the water to move up through the capillary pores. So that water that you've added that's too much will stay right there. And so let's say I come along next time. I haven't got a good signal, so I don't know how much to give it. So in this case, I'll give it the same amount I did before. So now my water's up here. Over here, hopefully I've learned and I adjust my watering a little bit, so I water it about right. Now if I don't get it exactly right, that's not a big deal. If I overwater it slightly, it's still going to draw the water back up in there as the pot begins to dry out. And most of the time the plant's going to take a little bit. But in this case, all that area up here is now, there's no plant, nothing can grow down here because all I've got is water down here. The roots can't grow down there and the water can't move back up. So now I'm up to my third watering. Here, no problem. I've taken care of it. Where am I now? I'm up here with my water. So what does that do? Now all of a sudden I learn, holy cow, that thing is not drying out. I'm giving it way too much water. And so maybe now I adjust, but what have I done? My pot, instead of being this big, is now this big. And what have I done with all this water down there? Nothing. It just sits down there and creates a swamp. Now, that swamp will eventually smell. So what people do is they put activated charcoal down there to counteract the swamp that they shouldn't have been there in the first place. So the idea of putting rocks in the bottom of a pot without drainage is like having, rocks in your head. It's not a good idea. Now, a lot of horticultural books will tell you to do this, but they haven't thought it through properly. This is, and they haven't had a lot of people bring their plants in to have them transplant them like I have, and gotten this swamp water dumped all over their apron or their clothes as they transplant a pot for somebody. This is just not a good idea. Now, how did the idea of putting rocks in the bottom of a pot get started? Well, simply this. It used to be the pots that we used had a single hole in the bottom of the pot right there. That was it. And if you grew things like lilies or others that had a high oxygen requirement, then what you did is you put rocks or chipped pieces of pottery or something like that around the bottom, and what that did is it wasn't for drainage, it was to allow air to get in. So air would come in, enter that hole, and it could spread through the soil and then migrate up into the pot like this. Now, very few pots we use now have a single drainage hole. And even if they only have a drainage hole, the soil mixes that we use now are much coarser, much more larger pores are found in those soils, and so generally you don't need this kind of a situation. Okay, so if you don't have a drainage hole, just have good soil to the bottom. If you do, and you're worried, like you're growing a lily or some other bulbous plant, the bulbs require a lot more air. Then if you want to put some gravel on the bottom to allow air to come in, that's fine. No big deal. But if you think of it as something to provide drainage, my friend, you're doing the wrong thing. It's not going to work, and it's not going to benefit your plant. Okay. Let's talk about a couple other things that are very common in houseplants. Here's how I've got a pothos, and you'll notice I picked this one out because you see we're getting quite a bit of yellowing in the leaves, if you see that. Okay? Now what causes this, and sometimes you'll go along, the plant will look really good, all of a sudden you get a lot of yellowing of the leaves. Let's talk about why that happens. Well, first of all, this plant is rather subject to it. This is a pothos. Some people call it a variegated philodendron. And if you let this plant get real dry, the plant roots are producing a hormone called cytokinin. And the cytokinin translocates to the top of the plant and keeps the plant leaves young. I call it the kickaboy joy juice of a plant. Namely, if the roots produce this on a continuous basis, translocate up to the leaves stay younger. You can take a leaf like this, and you can put a drop of cytokinin on the leaf, and inside that drop it'll turn right back green again, because it's the juvenility hormone of the plant. Without the juvenility hormone, the cytokinin, the leaves develop what's called galloping senility. That's my own term, galloping senility, but rapid onset senility. So the leaves age very, very rapidly. How do you avoid that? You just don't let the plant get too overly dry. This plant is bone dry, and it's probably been missed watering a few times. I found it in the corner of the greenhouse where it just got missed a lot of water. Now, are there other things that cause the plant leaves to yellow? Yes. What are they? Well, one of them is to have the leaves rot off. If they're rotten, they're not going to produce cytokinin, so the leaves won't get their juvenility hormone either. I don't know if you can focus in, but if you look at this, these are very healthy looking roots. In fact, if you pull out a root, if you look really close, at least from my perspective, I can see the root hairs. And even your larger roots are nice and healthy, the tips are nice. So this is not rotting off causing the the senility on the leaves. This is underwatering. And basically it's too infrequent of watering. So they've got to increase the frequency of watering. Now let's look at one other plant. Okay, this is a mixture. Interestingly enough, here's some nice healthy roots. But over on this side, if you can zoom in, these roots are rotted off. And these are, if you take a hold of the root, sometimes you can pull on the root, and the root, the outside of the root, the epidermis and all that will just come right off in your fingers, and what it will leave is just a little steely wire-like center of the root called the stele. That's the only part that's left, and the reason is all the rest of it's rotted off. Now these roots on this side are not producing the cytokinin the top of the plant needs, and so as a result, if I were to look at this plant, because, well, I wouldn't be too concerned because there's some good healthy roots on this side, but if the whole pot looked like that and I had yellow leaves, I'd say, oh, this plant's been overwatered. So you'd have to cut back on your watering to correct that yellowing problem on the top of the plant. Okay, so let's talk about soils for just a minute. This is what I call an ideal soil mix. If you look at this, it's coarse. It's you can see a lot of coarse material. This happens to be a peat-based mix. I like peat-based the best, but soil mixes with bark and other materials can work very well. The reason I like peat is it holds fertility very well. It tends to tie up your fertility and hold it in the soil. Also holds a lot of water, and so and it allows a lot of air to pass back through the soil. So I consider it kind of an ideal mix. You'll notice there's a lot of coarse material. It's got perlite. It's a little harder to see the vermiculite, but there's vermiculite in here as well, and that allows for a lot of air and other materials to pass through the soil. So that's what I like in a mix. If you don't know, if you get a mix and you buy it, it's nice and pretty black, and you take and put it in your hand and smear it, you'll find a lot of your soil companies, they'll dredge up sedge peat out of a peat bog. I've been to one of those bogs. It stinks like heck, but those bogs have real the peat moss that you have in those, it's called black peat or sedge peat. You can take and smear that in your hand, and it goes down to the same particle size as clay. Well, none of us would think we should grow plants in clay, but we put them in soils like that all the time, and we think they're going to do well. And they have various kinds of names that talk about how wonderful and black the soil is. Not necessarily a good idea. I'm not saying black soils can't be good, but you want to avoid soils where you can smear the main particles of the soil into your palm of your hand, and it just becomes a smear on your hand. Okay, let's talk about one more thing, and then I think we need to summarize and talk about what then makes a green thumb. Okay, if I were to tell you how to fertilize, it's very simple. If you've got a plant in a bright sunny location in your home, or at least it gets a lot of light, I would take any kind of good houseplant fertilizer and follow the instructions on the label. The label tells you to fertilize this amount, this often, do it. Now I will put the one caveat in. If I took a small plant, say something is just starting out, and put in this great big pot, number one, I wouldn't water it very often at all, because it'd take a long time for that plant to use the water. And number two, it'd take a long time for it to use the fertilizer up. So if the plant is proportional to the pot, follow the instructions on the label. Secondly, if a plant's in a dark spot, or in even medium light, I would cut down the proportion that they say on the fertilizer, either by fertilizing less frequent, or by giving it less with each. Let's talk about some of the things we talked about here. The question was, how often should I water? How many of you said every day? Well, not generally good. There are a few plants that you do that with. Azaleas, hydrangeas indoors, you may have to water them daily, or hanging baskets are hanging outside, the wind's blowing and they're drying out fast, maybe you have to water them daily. But indoors, typically not. And I say never water without checking the soil. The secret to the green thumb is the dirty fingertip. The second water was, how much water should I use? Water until the soil in the pot has saturated the capillary pores and the larger pores have drained free. How do you know that? Well, initially you don't. You got to do trial and error. How long is it taking to dry out? Is there, if the pot has drainage, how much drains out of the bottom? That brings us up one other quick point we need to mention, and that is, if the pot is standing in a drain, be darn sure you're not you're dumping that drain out. Don't allow a drainage container to hold a lot of water and to keep the bottom of the pot in water. That's not. Okay, second one, the third one was, what's the best soil mix? Well, obviously coarse mixes are the best. Peat or bark or both can work fine. Avoid real fine mixes for most uses. Those are specialty mixes, not generally that good. How much gravel and activated charcoal should I use in the bottom of my pot to provide drainage? Never count on rocks or gravel or broken pottery to give drainage. They were only used to provide aeration at the lower portion of the pots, not with drainage, and they were used with older, less porous soil mixes. We don't want gravel or activated charcoal in the bottom of the pot. Not a good idea. And why do my leaves yellow? Yellowing can be a result from lack or too much or too frequency of watering. I should mention one other one. We haven't talked about indoor plant pests. We can do that with a subsequent lecture. But one of the pests that's very frequently found on indoor plants is red spider or two-spotted mite or European red spider. They can cause a lot of yellowing, a lot of damage. That yellowing is usually kind of mottled. And hopefully in a future lecture we'll show you what that looks like. But we're just talking about care here, so we're talking about yellowing of leaves, lack or too much or too frequent of watering. Finally, how often or how much should I fertilize? Fertilization with a balanced blend of houseplant minerals should be used in accordance to package directions if the plant is getting excellent light, and if the plant should be proportional to the pot it's in. In medium to poor light, reduce the amount of or decrease the frequency of the fertilizing accordingly. Okay, so if you want to do that, you're going to be like a lady one time. I had a gal who I'd given a lecture similar to this, and I happened to run into her about 3 months later. And she came up to me, she said, "Dr. Gibby, I attended your lecture." And she told me when. I said, "Oh." She says, "You know, I don't do a single thing differently in the care of my houseplants than I did before your lecture. But you know, the funny thing is I couldn't get anything to grow before, and now they're all growing just fine." Well, obviously she was doing a few things differently, and the idea is you do a few things differently. It's not complicated, it's simple. Green thumbs grow on anybody who follows these simple steps. I hope you'll have a good day and fun growing your houseplants. See you next time.